Let's back to our lecture file. Let's finish the last topic for this lecture, classifiers. What are classifiers? Classifiers are the models we use in our classification. Like our example earlier, the chronic kidney disease. We have our function by putting the patient's glucose and hemoglobin value. So we'll return they are class 0 or class 1. So that function or model we use in the classification are classifiers. So in machine learning, a lot of time we hear about that, we say training a classifier. So here the training the classifier actually is, we just try to build our classifier. Remember, we have our sample data for the attribute, for example. We're passing through the data into our classifier. That's our input. So then through the classifier, we have our output is predicted label for the example. So here the label are the categorical output we are talking about. So when we say we're training a classifier, actually we just process the data from our sample data through our model. So when we say training, it's just because a lot of time we use a huge data. It's taking time to process the data. So that's what we call training the classifier. So after you have those attributes for your individuals, we passing through to the classifier. So then we can get our categorical output. So of course, we try to get the sample data from our population. And according to our sample data, we get passing through, sample data is our input for the attribute to passing through the classifier. So then we get our output we call labels. Most of the time when we have a big set of the sample, we are not only use all the sample to train our classifier. Instead, we do use a big amount of our data, maybe 80%, 90%, 95%. We're using that we call training set to train our classifier, our model. So the model associates between attributes and the label. Also, that's our unexpressively. The model or the function classifier we use, we don't reveal to outside. So that's we're using those, most of our sample data as a training set. So then we will to model the association between the attribute and label. On the other hand, that's mean to model the association between our input and output. So then we will use those smaller amount sample data set. So then we will estimate the accuracy of our classifier. So one classifier actually is very famous. We call that the nearest neighbor classifier. So what is the nearest neighbor classifier? We use the label of the most similar training example. So on the other hand, that means we have our nearest neighbor classifier when we have our attribute of the example. So then we get into our classifier. We will find the most similar. On the other hand, the most closest neighbor to represent our predict label. So this one actually you already saw that example. Remember before we're using the parent's height to predict the children's height. We're using the average for the parent height. So then we make that 1 inch for each interval. So for example, if we have the average parent height 68 inch, so then we just get the 68.5 to 67.5. So that's kind of using one value to represent that region. So the same thing is like the nearest neighbor classifier. Whenever we have our input, Okay, so then we're using our existing data. So this input, we will find the nearest one. Then we're using that label, that output, as our input data's label. So one thing you can see this picture, you will see what does that mean. So that means the same thing we're still trying to get from our population, right? We have our sample data. So our sample data, we're using that as a training set. So this training set, we have our distribution for our data. So then whenever we have the test data, the attribute for our input, we just find this new input, which existing training set has most close to this input. So then we use that note, the label, to represent the new input. So that's here, what do we mean? Okay, so what's the data you want to find the label on, you passing the attribute for that example. So then we're using our existing, actually is the older training set, all existing data we have. Then we find which data is most close to that example. So that data's label will be our predicted label for our example. I think the most important thing, let's see the example so you have better understanding. So that's back to our demo file. So the same thing, this one we're still using our chronic kidney disease file. Okay, we're using that table. So one thing a little different is, let's make all the, so here we still have our glucose, our hemoglobin data. We also have our white blood cell count. Okay, then we have our label, that's class. So all those columns actually, that's converted to the standard unit. Okay, so remember, we just convert to the standard unit. The distribution for our data should be still the same. Okay, so then, yeah, we have our color table. We're still using the class 1 is dark blue, and class 0. So who not get the chronic disease, kidney disease, that's the class 0. So class 1 is the gold. Okay, so that's why you can see the scatter plot like that. Also, this one we still use the hemoglobin and the glucose. So that's why you can see the distribution is still the same. The only thing different, we're using the standard unit. Okay, so now what's different before is we're using a function to return they are class 1 or class 0, right? Okay, so we just compare the data. So this now, we still compare the data. We still have our input. For example, here we have Alice. So Alice, Alice hemoglobin is 0. Okay, that's standard unit. Okay, so the glucose is 1.5. So when we try to, we got Alice the input data, right? So when we try to find the class 0 or class 1, actually we're just using the show closest. So this show closest is what? We find which point, we already have those existing points. So then Alice is the red one. So then we find which point has the shortest distance. That's the closest neighbor. So then that's the point we have. So then this one, since that's the class 1, so that we have the Alice is class 1. So the show code is, they see here we just make the point 0.2. So this one is the shortest distance. Yeah, so this is the nearest neighbor classifier example. So from the nearest neighbor classifier example, we can see here, so since Alice is here, so then this one is the shortest distance, the close neighbor. But we can see here, actually this one kind of very close to the class 0, right? So on the other hand, if the data from Alice, if they kind of move a little bit here, so our decision will be changed. So on the other hand, here, actually for the nearest neighbor classifier, we have a boundary we call the decision boundary. Okay, so we see what does that mean. If the Alice earlier is 0 and 1.5, right? But if Alice on the glucose a little bit lower, okay, so then he bring down to here, then we will find the show closest. So the nearest neighbor for Alice actually changed. So they changed to this point, and this point located in the class 0. So then our decision changed. So this one we call that's the decision. So here kind of have a boundary here. Okay. So on this region too far, they will be class 1. But if a little lower here, they will become class 0. So that's why we kind of know somewhere here is the boundary. So then, do you want to find a boundary? Yeah, we can find a boundary. So how we find a boundary is we just create all the points. We make that as like the grid of the point. So that's why here you will see you can just make the points like that. So this one, of course, is not the whole thing. Yeah, actually, we kind of just zoom into here. Okay, we just zoom into here because you can see from here, this location definitely they are all class 1. So we see the decision boundary between the class 1 and the class 0. Actually, they are around here. So that's why we just zoom in this location. Okay, we don't need to have everything. Okay, so from here, actually, see this is the boundary we will have. So how to find the boundary? Okay, so that's why here they showed. So after we make that all become grid, the point on the grid. So then we plot all the points for the classifier. Okay, so then we will see here, they will become like this. So then actually I run again. Yeah, so that's why it takes a little while because we need to have every point we try to find the closest point, the nearest neighbor. So that's why your boundary will take a little while to run. So this one here, actually, that's the, we just show, actually we just make all the points to calculate that point is class 1 or class 0. So of course you can see all the points is the grade. Okay, so that's class 0. So all the point is yellow, that's class 1. So on the other hand, here is our decision boundary. Okay, so on that boundary, to the bottom or to the right, they are the class 0. So then if the glucose is little higher or hemoglobin is little lower, they will become class 1. And you can see here the boundary, the shape of the boundary actually affected by our sample data. Because here you have a class 1. On the other hand, if this point is gone, it's possibly everything here also become, they have bigger region for the class 0. Okay. So that's we call that's the decision boundary. So decision boundary, or we say the nearest neighbor, when we train our classifier, so your result actually is very affected by the sample data you have. Okay, so that's me. See, just like earlier we said, if the class 1, they are gone, okay, actually our region for our class 0 will become bigger. But on the other hand, of course, if the class 1 a little lower, so then they will make our class 1 region will become a little bigger. So the most important thing is here, when we're using the nearest neighbor classifier, before we say when we train a classifier, we have all the sample data, right? We have that 80% or more, something, we have bigger portion for the training set. So then we use the test set to see our accuracy. But when you have your nearest neighbor, we will see more example in the next lecture. But one thing is, whenever your classifier, how we will check the nearest neighbor, we all have the existing training set there, exists there, because we use that to find the nearest neighbor. Also, then when you have a new data get in, we're using existing training set. So then we got our prediction label, or predicted label for that example. So then, of course, if you have more training set, then your decision boundary shape may also be changed. So that's our first lecture about the classification. We will continue to finish or see more example about the classifier in lecture 36.